Hello, everyone.
Hello.
I would like to ask you download these files. I sent by chat, or you can open in Canvas. And also, I strongly recommend to have paper and pen to write down something. First question is, will we have quiz? Always you can see in the syllabus when we have quiz, when we have exam. Syllabus may update it sometimes, but on the Canvas, it will be always updated. And moreover, as we told, in the every class, we have quiz. And maximum point, what you can earn from this quiz is 1 point. But by these quizzes, you can earn totally 25 points. And quiz, I can quiz, we will plan when we start class, we will plan when to have quiz. So let's plan today's class. First, I would like to do some practical exercises about logical equivalences. Also, by based rules of equivalence, we can simplify statement forms. I will share now my screen. And first, I have a question for you. First, I would like to ask, what can you say about this
they are equivalent?
Yes, absolutely. It's called De Morgan's rule, and it's one of the important, and I want to recommend you to remember it very well. Now, my next question is, what do you think? How can we prove it that this is really equivalent?
Using truth table.
Yes, absolutely. Using truth table, and you should know how to construct truth table. So let me show this. So we have here two propositional variables, P and Q. And for P and Q, we should assign propositional values. Propositional values, they are true and false or 1 and 0. And we should assign all combinations So all combinations, I mean 1, 1, 1, 0, 0, 1, 0, 0. Now, next column, what we need is P and Q. P and Q. Do you remember? P and Q. When P and Q is true.
When both of them are true.
Yes, only in one case, when both are true. So this is case true, and here we have 0, 0, 0. Next column, it's negation of this. P and Q, negation. And negation, it means it will be here negative, it will be false, true, and true. Okay, next, a negation of P. Also, we need negation of Q. And finally, we need disjunction of we need here disjunction. So negation of P, 0, 0, 1, 1. Here we have 0, 1, 0, 1. And now disjunction. In the disjunction, only in one case, we have here 0, 1, 1, 1. And now we need just to observe to these columns. They are absolutely the same. And it means that these propositional statements are equivalent. Any questions about it? So this is complete solution of this problem. If you asked to prove that this statement form is equivalent, you need just to construct truth table and then compare appropriate columns. Okay, no questions. What about if we have three propositional variables? When we have three propositional variables, we need all combinations. All combinations, it means we have 8 rows. For example, here in these files, please open a lecture 1 file, and on the end of this lecture 1, logical equivalences. It's last page.
Where can I find that file?
So on the module, in the section module, below you can find the M1.
Oh, okay, lecture1.pdf.
Yes, absolutely. So find the last page, and there we have logical equivalences. All of these logical equivalences can be proved by truth table. And for example, what about distributive law? Here we have two distributive laws. And let's rewrite first one. So P and Q or R, it's equivalent P and Q or P and R. By the way, you know very well that we have similar distributive law for ordinary arithmetic operations. And if you want to use this distributive law effectively, I recommend to remember ordinary multiplication rule for distributive law for ordinary multiplication. For example, in this case, P multiply Q plus R, and it equals P times Q plus R. Okay, so to prove it, what we need? We need to assign all truth values to these propositional variables, P, Q, and R. You can do it anyways, but I recommend first to assign two propositional variables values. For example, P and Q, 1, 1, 1, 0, 0, 1, 0, 0. Then copy them 1, 1, 1, 0, 0, 1, 0, 0. And now for the first, you can assign R true 1, 1, 1. And then 0, 0, 0, 0. So in this way, we will get 8 rows. And now about columns, here we will have Q or R, then P and Q or R, next row P and Q, next row P and R, and finally this expression, last row. And we will compare values of this column with last column. And they will be the same, and it's proof that we have distributive law. I would like to ask you that to finish this proof, and I believe you can do it without any help. So now open now please lecture 1 problems. Lecture 1 problems. And find here number 14. Number 40 to 43. So here in these problems, we need to construct truth table, and by this way prove that these expressions, these logical statements are tautology or contradiction. So what it means? For example, let's let's do 41. By the way, problems which are indicated by blue number, it means that they have solutions, and solutions you can find in the textbook. Blue numbers, all blue numbers have solutions or hint or answers. Okay, now P and Q. Now let's do 41. Okay, what we have here, P and not Q, and not P or Q. So we need to construct truth table. Please, I will give you about 30 seconds and start you to construct truth table, and I will follow you. It's very important to do independently these exercises. So we have two variables, P and Q. We need not Q. We need not P or Q. And finally, we need, not finally, but we need also P and not Q. And finally, we need all this expression here in the last column. Now, let's assign values 1, 1, 1, 0, 0,
We also
1.
need not P.
Not P or Q, P and not Q. In which column do you mean? This
Just, in the second part of the first statement, there is not P or
yes,
Q.
yes, you are right. But you know, this I missed to write this first one, and I wrote second part.
Okay, sorry.
No, you are right. I just missed. Okay, now not Q. Not Q, it's 0, 0, 1, 1. Not P or Q. Oh, I missed also one column, not P. Not P. Not P, not P. Here is 0, 0, 1, 1. So now, not P, Q. Not P, Q. It will be only 1. Not P and Q.
Will be one true and 3 falses.
P and Q. Only second false, yes?
Excuse me, I think that there is a mistake in not Q. It should be 0, 1, 0, 1 instead of 0, 0, 1, 1.
Oh, thank you very much. Absolutely. Not Q. Here must be 0, 1, 0, 1. Okay. Now, not P or Q. Here, not P or Q. Here we have only in the second here, and others are true. Is it correct now? Look very critically. I like very much when you not agree with me.
Yeah, it's true.
Okay. Next, P and not Q. P we have here and not Q we have here. And it's only one case there. True. It's first. And agree or disagree?
Agree.
Disagree.
Yeah, I
Because,
disagree.
Q is false.
I disagree as well. It should be 0.
Not Q, it's not
0,
Q,
0.
so
Which column do you mean?
only the second one is true. Others are false.
Yes.
Second one is true. Okay,
Yes.
thank you, thank you. Is it correct now?
Yes.
Thank you. Now, agree or disagree? Agree or disagree?
I agree.
I agree as well.
Okay, thank you, but agree or disagree, it's tautology, and it's always true. It's just joke, but take it in account. Agree or disagree, it's tautology. And you can always say yes.
It's
Or-
contradiction.
No, it's not contradiction, it's tautology, it's always true. Agree or disagree, it's always true. Like to be or not to be, always true, tautology. So when professor asks agree or disagree, you can always answer yes. Or you can say that, please, your question is not correct. It's tautology, it's always true.
But this is contradiction. It's always false.
This is contradiction. This should
or
never be
it's-
true.
No. Or it's disjunction, it's always tautology. Or
But
agree.
we have and here.
We have and here, so it's never gonna be true.
You mean this example?
Yes.
Okay,
Yes.
okay. So this is contradiction. Yes, absolutely. If, oh no, I will write down zeros. Oh, okay. I thought you discussed with me about my phrase, agree or disagree, and that's why. So it's tautology. Now,
Oh, sorry. There is made mistake. In P and not Q. Last one is false. Yeah, oh, sorry. Oh, okay.
okay, no problem,
Okay.
no problem. Always you can ask, and it's very important to look critically. So, as we told, truth table, it's very, very powerful tools, very powerful to prove logical equivalences. But I think you will agree with me if I will say that it's not very pleasant activity to do truth tables. But if you are more clever, you can avoid truth table to prove something using basic logical equivalences. For example, in this example,
I am completely lost as to what is going on here. P stands, this is just binary computer logic, right? What does P stand for and what does Q stand for?
what do you mean stand for?
What these are values. What is a p-value and what is a q-value? I'm very confused as to what's going on here. Which one is the true value? Which one is the false value?
So, P, do you mean what are P and Q? They are propositional variables. They are propositional variables. And we denoted it by P and by Q, some propositions. They called propositional variables, and they have, did you attend previous class?
No, I overslept.
Oh, but you can find these materials, but I will tell you now. So P and Q. First of all, you should know what is proposition. Proposition is sentence which is true or false. So propositional variables have two values, true and false. So, but you need to visit first class, and also I can post on this module link of this previous video class and today's class as well. So if someone who missed this class and oversleep can watch this video.
Where can I watch the video?
Yes, sure. I will post this link. I recording this.
Okay. You will post it where?
In the module.
Okay.
In the module. First class, I denoted it by M1, and today's class, I will denote it by M2. And I will post there every materials after each class. So I told about that truth table is very powerful, but it's not very pleasant to construct truth tables. But if you are more clever, you can avoid construct truth tables and prove by using basic logical equivalences. Basic logical equivalences. I mean what is in the last page of our first lecture. For example, I will show in this example. We proved that P and not Q and not P and Q, we proved by truth table, we constructed truth table, and we proved that this is false. This is contradiction. This is false. Now let's show it without truth table, just to simplify this expression using basic formulas. So P, I will rewrite first part without any change, P and not Q, and now here I will use well-known, I hope know it. It's very important to come and to repeat previous class before we start new class. So by De Morgan's rule, how can I write this part? Any idea? I mean, I will write down here, not P or Q. What I know about De Morgan's rule? I know about De Morgan's rule. Not A or not B, it's equivalent not A and B. Now in this case, pay attention now. In this case, This I can write down like this: not P or not Q. Agree or disagree?
Agree.
Agree?
Yes.
Yes, yes, yes. It's true, because we know very well double negation, negation of Q, it's Q again. Now, I will use this formula, De Morgan's rule, for this particular case. Instead A, I have P, and instead B, I have this one, not Q. So we have, I will write first this negation symbol, not, and in the parentheses, we have A and B. A and B, in this our case, it's going to be P and what?
Not Q.
Q.
Not Q.
Not Q. Very good. Not Q. Because if you compare with this general formula of De Morgan's rule, it's exactly not Q. So here I will write down not P and not Q. So we don't need it. I can erase it. Okay, no questions so far? Equals. Any idea what is it? Now pay attention. If I will imagine it by A, I will denote it in my imagination by A. What will be this expression?
Not A.
Not A.
Not A.
Absolutely, not A. So what is this expression? It's just false, because we have A and not A.
Yes, it's contradiction, right?
Yes, absolutely. It's contradiction. So in few steps, we proved the same what we proved by unpleasant truth table. Any questions about it? Okay. One more example, please. Let's follow it. And 42. And would you like to prove by truth table, or we are more clever and we can avoid truth table?
Without truth table, I think.
Okay,
Easier.
without truth table. Without truth table. Please start solving and I will follow you. Try to solve and I will follow you soon. Any idea what can be first step? Or any idea about which rule can we use?
Is the like
Rule-
very first expression contradiction, like not P and Q
Not P
or
and
Q?
Q. Not P and
Not and or Q.
yeah, and not P and Q. Do you mean not P and Q? It's contradiction.
No, or Q. Not P and or Q.
Not P or us. Not P or Q. But here we have not P and Q or R and not Q. Please, in the lecture 1, in the last page, see again basic logical equivalences, and maybe it will help you to find which basic formula can we use.
We can use distribution laws.
Distribution or Salome, just a second, Salome. Distributive law, Salome, it's
Maybe, yes, distribution law.
okay. Distributive law, we have distributive law and we have associative law. Can you see this page now?
Yes.
I would like to ask you, all of you, to open these basic logical equivalences. So, pay attention now.
I don't see anything.
Rule
except
number
in
2 and rule number 3, associative law and distributive law. They look similar. They look similar, especially left sides of equivalences. They look similar, but there is big difference. And difference is that in the associative rule, we have the same logical operators. Only conjunction in the first associative law and disjunction in the second formula of associative law. As for distributive law, in the left side, here we have two logical equivalences. So to compare our ordinary operations, associative rule looks like this: A, B, C, and I can take parentheses any part of this. For example, A, B, C, or I can write like this. They are absolutely the same, and this is associative rule. Or in case of ordinary plus, I can take in parentheses any part. This one, and etc. So, when we have the same logical operators, it's more easy case because associative law in general, it's more easy case when distributive law. And associative, it's less complicated. In the associative law, we need just to take parentheses some parts. Now pay attention very carefully and tell me, in this case, in the number 42, do we have here the same logical operators or two logical operators? Two logical operators, I mean here in this case, disjunction and conjunction. And
Got
not
only one.
What?
We got only one operator, right?
Yes, we have only one operator. We have only one operator. And these operators, they are absolutely the same. And it's our advantage. It's very good for us because it's more easy to solve. Because we can use commutative rule and also we can associative rule. So let's let's write down it. Here we have not P and no, not P. Okay, I will write it without any change. Then we have and Q and Q. Q and Q I will write together. I will write it in the group. And R and not Q. Do you agree?
Maybe we do better write Q and not Q together, and then we know that it's always false.
Okay, oh, it's fantastic. Yes, it's very good. But I will get the same now. Now, Q and Q. What is Q and Q?
It's Q.
It's Q. It's Q. Now, I will group this Q, but I'm very glad to say that your idea, Katie, it was better, because if we group in the beginning Q and not Q, it's false. So I will do now the same. So we have now not P, not R, not Q, and not Q. And Solomon noticed very well that Q and not Q, it's contradiction, it's false. And now what we have? We have false and this expression. And it's always false. Any questions? Look very critically, and if any questions, don't hesitate. And also, if there will be some misunderstanding, you can post in discussion section, and I will answer all your questions. Okay. Let's go forward. Okay, now see now numbers 50, 54. 50, 54. And let's try number 51. Number 51. So, of course, these equivalences definitely we can prove using truth tables. But we pretend that we are clever and we don't need, when it's possible. It's not always possible. It's not always possible to prove without truth table. That's why truth table is most powerful tools. But when it's possible, we will prove without truth tables. And in the exams or in the quiz, there will be given, and you should prove with truth table, using truth table, and without truth table. So here it's required to prove this equivalence without truth table. So here we have P and not Q or P And we should prove that it's equivalent with P. How can we do it with truth table? We will construct truth table, and in the last column, we will have these expressions values, and we will compare with values of P. If they are the same, it means that they are equivalent. But now we will try to prove without truth table. So please start this proof and I will follow you. But let's recall well-known distributive law for ordinary arithmetic operations. So in this case, instead multiplication, I have conjunction. And instead plus, I have disjunction. So let's follow this rule, and what we have, P multiplication here. So I should write disjunction by negation of Q or P and P. Do you agree?
Yes.
Thank you. Okay, very good. Now I have a question. What happens if I will write this expression without parentheses? Does it change something?
Yes.
It will not change nothing because we know precedence in logical operators. First, it's negation. Next, conjunction, disjunction, and then implications, and I will discuss it later. It will not change nothing because this conjunction and this conjunction, they have precedence over this disjunction. But I wrote parentheses for more visualization. So the next continue. What we have here, we have P and not Q, or P and not Q, or P and P. What is P and P?
Just P.
It's
Yes,
just P.
just P, of course, it's just P. So P. Okay, how can we continue? Any idea?
We can write P.
Please
as
try now to solve yourself and tell me if you will get. We should get answer P.
Can we just look at the absorption law and like say logically that it's not true?
Oh yes, yes, I agree. We can do it. Absorption law, and this absorption law, it's number 10. Number 10. Okay, it's very good idea. It's very good idea because we have absolutely the same absorption law, first absorption law. I agree, it's a very good idea. However, I would like to prove this absorption law, and prove not by using truth table, but by logical simplification of expression, and try to prove it, please. It looks, if you will open parentheses by distributive law.
I got the question. Isn't no, not Q, just P? Wouldn't it be, if we use the negation rule, wouldn't not Q be P, and we will get P and P or P?
Lasha, say again.
So wouldn't not Q be the same as P?
Not Q is the same as P? Lasha, not Q the same as...
Isn't not Q the same as P in this case? Wouldn't it have the same definition as P?
No, Lasha, it's different. It's different propositional variable. P and Q, they are different propositional variables. Here, what we can now, so if we will use distributive law and if we will multiply it, looks you did try it, but not have good result. What if I will write down here like this, P and not Q, I just rewrite it, first part, or P and true.
Oh, I have an idea before you continue. I mean, if we write a Q negation and then write minus P and minus Q instead of P or Q, then we have this disjunction and we can write P and minus P.
Oh, Katie, good idea. Try it. I can't sketch everything what you said, but you can try it. And if you will get P, it means it's good, it's correct, it's good way. Try it and upload your file. Okay, so here, do you agree that I can, instead P, I can write P and true? Do you agree with me?
Yes.
Of course, because they are equivalent. Now I can use now distributive law. And to be more clear, again, I will compare it with ordinary arithmetic operations. So we have here P and not Q or true. Please look critically. Do you agree?
Can you please explain this step again?
Okay. So we have, is it clear how I got this expression?
Yeah, that's clear. I mean, after
Yes. Yes, I just instead P, I wrote down P and t. Okay, now I will write down here ordinary multiplication distributive law A times P plus C. Now,
Yes,
compare
now
now.
I understand. Yeah. Okay.
Now compare. If you will compare, there no way you will understand it. Now, let's now continue. Here we have not Q or T, not Q or T. And what is not Q or T?
It's always true.
Absolutely, it's always true. True and true or any propositional variable, it's always true. So we have P and T, and it's going to be
P.
P. It's going to be P. Okay, any questions?
ერთ კითხვა მაქვს. აი, მაღლა როგორ წერა, აი შემოხაზული რო გაქვს, ანუ მაგის მერე, ანუ რა საჭირო იყო, ანუ ხო იყო რომ P და not Q და მერე იყო ისა რა ქვია P, ანუ P და not Q ან მარტო P უნდა უდრიდესო P-ს, ანუ ერთ-ერთი ნაწილი ხო ისედაც P იყო და რაღა აზრი ქონდა მაგის მტკიცებას.
ამის შემდეგ?
არა, მაგის გვერდზე.
So far, are you agree? Yes?
ანუ ხო აი მაგის მერე რა საჭირო იყო ამის მტკიცება, ანუ ერთი ნაწილი, მეორე ნაწილი ხო ისედაც ყოველთვის P არის და მაგათ შორის კავშირი ან არის, ანუ ერთ-ერთი წევრი თუ მაინც P არის, მაშინ მაინც P გამოვა.
P and not Q, it's not P.
არა, მეორე ნაწილში P and T არის მანდ, ანუ ხო P არის ეგ ნებისმიერ შემთხვევაში.
P and true. P and true, it's not true. It's P.
ხო, ანუ P არის და ერთი ნაწილი მთლიანად P გამოდის, მეორე ნაწილი.
So we have here P and not Q. And what is your idea, say again?
ანუ P და not Q ხო არის პირველი ნაწილი. და მერე მოყვება ან კავშირი და მერე არის P და T. და ეგ ხო იგივე P არის. მეორე ნაწილი.
ამაზე მეუბნები?
კი. ეგ ხო P არის.
ეს ხო P იყო და დავწერე P and true.
კი, ხო და P რო არის მაგის გამო რა საჭირო იყო დანარჩენი მტკიცება შუაში კავშირი ხო ან არის, ანუ ერთ-ერთი წევრი თუ მაინც P არის, მაშინ P გამოვა და P-ს ისა equivalent.
არა, არ არის მართალი, it's not true. For example, Q or P. ეს ხო არ არის P.
არა, კი, მაგრამ ანუ ერთ წამე
One part here is P, but this disjunction is not P.
Oh, okay. I guess I get it.
So now we need to write down our first quiz. And now sign in Canvas and find assignment section. Find the assignment section. And here I will now publish this quiz. Can you see quiz 1 in the assignment section?
Yes.
Okay, so you can write down it on the paper and then upload, or you can write in the canvas.
How much time do we got for this quiz?
15 minutes.
Quiz 1?
Quiz 1, yes.
It was video quiz, yes, I remember.
No, not video quiz. I removed this video quiz. It was just my assignment, and that's why I did it. My training assignment, it was to make video quiz. Quiz 1 in the assignment section.
Oh, yes, I saw.
Wait, so we don't have to do the video quiz?
No, not video quiz. Quiz 1.
And when is quiz 1 due?
No, right now.
What?
In the assignment 1, find quiz 1.
Excuse me, we first have to watch the video and then we can answer, right?
Oh, it's not video quiz.
I only found the video and the quiz instructions, but where's the actual quiz then?
No. You should visit not quiz section, but assignment section. Assignment section, and
Okay,
there
I
is
see.
quiz 1.
Okay, I got it. Thank you.
უკაცრავად როგორ გზავნით პასუხს?
მანდ არ არის სასატვირთი? ატვირთვის საშუალება არის, უნდა იყოს მათ სადღაც.
ოკეი.
ფოტო გადაუღე და ატვირთეთ. ან თუ გნებავთ იქვე დაწერეთ, როგორც თქვენთვის მოხერხებულია.
We need to write our names on the papers.
Yes, yes, Luca.
Okay.
I'm not sure that without it, I will identify you.
I already submitted it, and can I leave?
Just a minute. Yes, here's one submission, Salome. I hope it's yours. Good job.
Thank you.
Professor, can we get 2 or 3 more minutes, or maybe 5?
Yes. It's first quiz, and I can add time.
So is it okay if we get like 5 more minutes? Professor?
Yes.
Is it okay if we get a couple of more minutes for submission?
Yes.
Okay, thank you very much.
It's for first quiz, because it's first quiz today, and that's why maybe you need to use this canvas and
So can we leave now?
yes, you can.
Okay, goodbye.
Bye.
I have a question.
Okay, Katie.
Is it problem if we don't write truth table in a very detailed way? I mean, if we just do it in our head and write the full sentences, for example, not partly as you did on the lectures.
You can write as it's comfortable for you.
Okay, thank you.
Hello, I finished, but my submission isn't coming.
But Jakob, say again.
Basically, I want to submit, but photo doesn't like load into quiz. I don't know why.
Oh.
I'm waiting to submit, but it doesn't let me.
Wait, and I think it will be possible.
Okay.
Or if some difficulties, just email me.
Okay.
But wait, don't worry about it.
Hello, I have a question. Is it okay that I'm writing on a computer on OneNote?
Yes,